So up till now we have understood the definition of gamma function, and let's now we will see the formulas and some problems over it. So infinity is equal to gamma n. Second one is integral x to the power n e raised to minus x dx is equals to gamma n plus 1 from 0 to infinity. The changes here is simple, as we can see here it is n plus 1 and here is 1. So there is adjustment only 1 here. Now the third one is integral x to the power n minus 1 e raised to minus ax dx from 0 to infinity. So here is the only change is e raised to minus ax. So the formula changes by gamma n divided by a to the power n. So these are the three formulas which are essential in solving the numericals or the problems over it. And further we will see how to solve the problems. Now we have a question like gamma n plus 1. We have to prove that gamma n plus 1 is equal to n gamma n. So we know the formula as gamma n is equals to integral x to the power n minus 1 e raised to minus x dx from 0 to infinity. And also gamma n plus 1, we know its formula. Yes, what's its formula? Gamma n plus 1 is equal to integral x to the power n e raised to minus x dx from 0 to infinity. So now let us consider this is as LHS. Therefore LHS is equals to integral x to the power n e raised to minus x dx from 0 to infinity. So now to solve this, we know that we can solve this by product rule of integration. So we know that the product rule of integration as integration u into v dx, integration of u v dx is equals to u integration of v dx minus integral du by dx into integral v dx and the whole into dx. So this is the product rule for two function uv into dx. For multiplication of two function we have the integration of u integration uv dx. So we can apply this product rule to this integration and we can solve it. So by applying this, and also we know that another one, that is Eilert rule. So applying these two rules to this integration, we can solve it as like this. Inside the bracket, first u, this is u, this is v. Therefore x raised to n integration of e raised to minus x dx minus the whole integral d by dx of x raised to n into integral e raised to minus x dx into whole dx, bracket close. So now limits 0 to infinity and here is 0 to infinity. So we get x to the power n into e raised to minus e raised to minus x, this limit from 0 to infinity, whereas minus 0 to infinity d by dx of x raised to n, that is n into x raised to n minus 1, and the integration of this term we get as minus e raised to minus x into dx, bracket close. So after putting limits to this and after solving, we get this term as whole complete 0, and taking n and this minus outside of integration, we get plus n integral 0 to infinity x to the power n minus 1 e raised to minus x dx. So we know that this formula integral 0 to infinity x to the power n minus 1 e raised to minus x dx, this is nothing but gamma n. Do you notice that this is nothing but gamma n? Therefore we get answer as n gamma n, hence it is RHS proved. So now we have taken the second problem as integral 0 to 1 log of 1 by y raised to n minus 1 into dy, and we have to prove that this integral is equal to gamma n. So this is basically some tricky question. So let us see how to solve it. So first we write LHS is equals to integral 0 to 1 log of 1 by y raised to n minus 1 dy. Log of 1 by y raised to n minus 1 in dy. So we put this term, this bracket term is equal to x. So therefore we put log of 1 by y is equals to x. Therefore by adjusting we get y is equals to e raised to minus x. As taking exponential, 1 by y is equal to e raised to x and y is equal to e raised to minus x. Therefore differentiating we get dy is equals to minus e raised to minus x dx, right? So putting this in this integral, also here the limit changes. So how the limit changes? We will see it how the limit changes when y is equals to 0. So we see that when y is equals to 0, then x equals to infinity. Here only we see when y equal to 0, then 1 upon 0 is infinity log infinity, therefore x equals to infinity. Therefore when y equals to 0, then x equals to infinity. And when y equals to 1, then log 1 is 0, therefore x equals to 0. Therefore when y equals to 1, then x equals to 0. So putting all these things in this integral, we get our LHS equals to integral when y equal to 0, x equals to infinity. When y equal to 1, x equals to 0. Therefore log 1 by y, that is x, raised to n minus 1, and dy is nothing but our minus e raised to minus x dx. So okay, so taking this minus outside the integral, minus 0 to infinity x to the power n minus 1 e raised to minus x dx. So we know that property. Which property? That this integral a to b f of x dx is equals to minus integral b to a f of x dx. That the limit changes from this limit goes here and this goes here by just minus sign. Therefore the same happens here. Now we have integral minus 0 to infinity x raised to n minus 1 e raised to minus x dx. That is integral 0 to infinity by the property x raised to minus n e raised to minus x dx. So we see that this is nothing but gamma n. Okay, this is nothing but gamma n, because gamma n is equal to integral x raised to n minus 1 e raised to minus x dx from 0 to infinity. So hence we get equals to gamma n. Therefore LHS is equals to RHS. From the question we have know that we have to prove that this integral equal to gamma n. Therefore we have proved that LHS is equal to RHS.